Hello everyone, welcome back to the course on cryptography and network security. So today in this session we try to discuss on the new technique called transposition technique. In this class we try to discuss on introduction to transposition cipher techniques. Under the transposition cipher technique we'll be on discussing with rail fence cipher with suitable example and also double columnar transposition with example. So by the end of this session, the students will be able to understand the concept of transposition cipher techniques. They will be describe the working principle of rail fence and the columnar transposition. So performing the encryption using the rail fence and double columnar transposition methods. Now we understand how exactly the transposition cipher is going to be work. A transposition cipher is a classical encryption technique in which the positions of the plaintext characters are rearranged according to a specific rule. Unlike a substitution ciphers, letters are not replaced but their order is going to be get changed to generate the cipher text. The key characteristics in the transposition cipher: characters remains the same, only the positions are rearranged. The security is completely depends upon the pattern which we are going to be rearranging, and it is easy to implement but vulnerable to the analysis. And the common types of transposition techniques include rail fence, columnar and double columnar. So in this session we try to understand how the rail fence cipher and double columnar transpositions is going to be work. When it comes to the working principle of transposition cipher, the basic steps involved in the encryption: the first we need to be go and write the plain text in the structured format, so that is rows or in the zigzag pattern. Then we have to be go and rearrange the positions of the characters using a predefined rules. So and then we'll be go on reading those characters in a different order in order to produce the cipher text. And in the case of decryption, the original order of the character is going to get restored. So transposition techniques increases the complexity by scrambling the order of characters while preserving the original letters. So this is going to be makes the difference between the substitution technique to the transposition technique. In substitution technique we are replacing the existing characters, and in the case of transposition we preserving the existing characters but the position is going to be get rearranged. First we look into the rail fence cipher. So rail fence cipher is a simple transposition cipher where the plaintext characters are going to be represented in a zigzag pattern across the multiple rows. So that is we are going to be called as rails. After writing the message in the form of zigzag, the characters are read row by row to generate the cipher text. So the key points we need to be remember when we go on solving the problems on the rail fence. So it is going to be uses the number of rails as the key, and the characters we are going to be represent in the form of zigzag pattern, and the ciphertext we are going to be obtained by reading the rows sequentially. So here is an example to understand how the rail fence is going to be work. The plain text what we have taken is hello world, and the number of rails or nothing but the key we can call it as is 3. So I'm going to be representing the hello world without using any spaces in the given plain text. So I'm going to be representing, so first H I'll be go on representing, then E in the next position in the second rail, and in the third rail I'll be go on representing the third letter. Then I'll be go with 2 1 2 3 2 1 and 2. So this is how I will be go on representing the entire plain text in the form of zigzag in 3 rows. So those rows we called as rail number 1, 2, 3. Now the next step will become, we need to be go on read row by row. So once we have done with respect to this table, so the rail 1, so first row I am going to be reading as H, O, L. The second rail elements are E, L, W, R, D, and the third rail values will become L and O. So now I'm going to be representing all the 3 rows elements in a single row, that is we are going to be get the ciphertext equals H, O, L, E, L, W, R, D, L, O. So this is how we are going to be getting our ciphertext from representing the zigzag pattern and reading afterwards row by row. So when it comes to the second transposition technique called double columnar transposition, so in this case it is a stronger form of transposition where the cipher columnar transposition is applied twice using that same key. So what are the steps involved in the case of double columnar? The one, arrange the entire plain text in the table with columns equal to the key length. Then number the columns based on the alphabetical order of the key, and then read the columns according to the key order to produce the ciphertext. Repeat the same process again using the same or different key. So this becomes the double rearrangement, makes the cipher more secure than the single transposition. Now we look into the example to understand how the double columnar transposition is going to work. So again we are going to be considering the plain text hello world. The key we are going to be using is zebra. So first I'll be going to arrange the entire plain text in the form of columns. So here you can see that the key is going to be having total 5 elements are there. So I'm going to be write the 5 columns. So I'll be going to give the number for the Z is 1, E is 2, B is 3 and R is 4, and as well as A will be the 5. So I'll be going to represent the first 5 elements of the given plain text in the very first row of 5 columns. The next, the remaining the 5 letters I will be going representing in the second row. The next case is, now we need to be going arrange the key alphabetically. Suppose the zebra what I have considered, I will be going arrange it in the alphabetical order. So the original key is zebra. So 1, 2, 3, 4, 5. I have given the numbers for each letters in the original key. So when I'm going to be arranging the original key letters in the form of alphabetically, then the key value will become 5, 3, 2, 4, 1. So now what I supposed to do is the very first one. So I need to be go and read the column 5 element. So first, then the third column elements will come, then the second column elements, fourth column, and the first column elements comes at last. See here. So we are going to be reading the columns according to the column numbers. So 5. So what is that 5 in the previous table? OD. So OD I am going to be reading first. Then 3, that is third column, that is LR. Then 2, EO. Then the fourth one is LL, and the first one is HW. So this is how we are going to be reading out the column values according to the arrangements of the alphabetical key values. So finally, the first round of transpositions what we have done with respect to the plain text hello world, this will become the ciphertext at the very first transposition. Now when we go for second time of transposition, this ciphertext we are going to be considered as elements to enter in the given table. Either we can go with the same key or you can go with respect to the previous key. So any different keys. Now, so the same elements I will be go with respect to zebra 1, 2, 3, 4, 5. So OD, L, R, E, O, L, L, H, W, it becomes the new table for the second round of transposition. Again the same numbering again 5, 3, 2, 1. The first one is going to becomes as in the case of this. So fifth one. So what is the fifth one is EW. Then the third column LL. Second column is DL. Fourth column is RH, and the first column is OO. So finally, after the double columnar transposition, so we are going to be get the one more ciphertext, that is EW LL DL RH double O. So in this way, if more the number of transposition, the stronger become the ciphertext. It becomes difficult for performing the analysis. So finally, so the plain text what we have used hello world with the key value zebra, the first transposition got this cipher block, and the second transposition is going to be get this block. So likewise, we can able to go with respect to a more number of transpositions in order to make the ciphertext difficult to perform the operation to get plain text for the attackers. With this, I'm concluding today's session with transposition ciphers encrypt the messages by rearranging the positions of the characters. Techniques like rail fence and columnar transposition follow the specific patterns to generate the ciphertext. That is nothing but how we are going to be rearranging the original key. And these methods do not change the letters but alter their order to hide the original message. And this is going to be form the basic foundation for understanding the modern cryptographic systems. So with this, we are going to be ending today's session. We will come back with the next topic in the next session. Thank you.